Hello and welcome. Today in this video we will be revisiting our rational numbers. To do this revisiting of rational numbers here, we will be doing this exercise 1.4, and in this exercise two theorems you have to know it very clearly. Suppose if a rational number you have in the form of p by q, suppose x is a rational number, can be written in the form of p by q, then the prime factorization of q, if you find out the prime factorization of q, then it must, if it has these two factors, if you can write them in this form, 2 to the power n into 5 to the power m, then that rational number, if you divide it p with q, then the decimal expansion will be terminating. It will terminate. Like here m and n are positive integers. Suppose say 15 we are dividing by, or 5 we are dividing by 2. 2 2s are 4. Then 1 0 2 5s are 10. Terminates means it stops. You can see here very clearly. On dividing 5 by 2, the decimal value stops here after 5. So in this case, the number, if I am taking it as 5 by 2, this is your q, downside is your q. So this q I can write in this form, 2 to the power 1 into 5 to the power nothing means 0. Any number raised to the power 0 is equal to 1. That means I can write in this form, 2 to the power n into 5 to the power m. So I can say that this rational number x equal to 5 by 2 is a terminating decimal expansion. This is a rational number, but it terminates. When we divide it, it will stop. It will terminate. So if you can write in this form, then x terminates. Our x has a terminating decimal expansion. Then the next theorem that it says like this, the second theorem is given in your book as theorem 1.7. This is theorem 1.6. In theorem 1.7, it says like this: if x is equal to p by q, it is a rational number. If this denominator q cannot be written in this form, or is not equal to 2 to the power n into 5 to the power m, in that case x is a non-terminating repeating decimal expansion. So with this you will come to know, if it is q, the denominator is equal to 2 to the power n into 5 to the power m, if we can express in this form, then it will be a terminating decimal expansion. And if it is not of the form 2 to the power n into 5 to the power m, then it is a non-terminating and repeating decimal expansion. Let us take one example. Suppose x is equal to 10 by 7. Let us divide and see. 10 by 7. 7 ones are 7. 3 0. 7 fours are 28. 2 0. 7 twos are 14. 6 0. 7 eights are 56. 4 0. 7 fives are 35. 5 0. 7 sevens are 49, then 1 0 7 again starts here. This 10, we started with this, again we got 10. That means these digits are going to repeat now. 1 4 2 8 5 7. Again 1 4 2 8 5 7. Like that it will go on. So it will represent a non-terminating and repeating decimal expansion. If you take the rational number, if the denominator cannot be written in this form, we know that 7 cannot be written. 7, if I try to write 2 into how much? In terms of 2 and 5, cannot express 7. So it is not possible. So it will represent a non-terminating and repeating decimal expansion. So like this, you can identify. And to tell you in simple words, if any rational number you get it, suppose x is equal to 5 by 7. So what you will have to do is, this denominator prime factorization you will do and think and see, can I write like this or not? As product of 2 and 5. If you can write, that means it terminates. The rational number will terminate when you divide it. You don't have to do manually, just you know by looking at the denominator. And if it cannot be written in this form, 2 into 5, which is prime factors 2 and 5, then we should know that it is a non-terminating and it will be reoccurring decimal expansion. Let us do the exercise question and see now. Question number 1 from exercise 1.4. So here the question, it says, without actually performing the long division, you don't have to divide it in long division method, state whether the following rational numbers, that means all the given numbers are rational numbers, will have a terminating decimal expansion or a non-terminating repeating decimal expansion. As discussed earlier, terminating, then you can write in the form of 2 to the power m or 2 to the power n, 5 to the power m. If it is non-terminating and repeating, then we cannot write in that form, 2 to the power n, 5 to the power m. Let us see some few questions I picked up from your book 1, 2 and 3. Now what you have to do is, the first one, 13 divided by 3, 1, 2, 5. Nothing to do, we don't have to divide. This number 3, 1, 2, 5, we find out its factors. 3, 1, 2, 5. Product of the primes will find out. 5, 6 are 30, 5 2s are 10, 5 5s are 25, 5 1s are 5, 5 2s are 10, 5 5s are 25, 5 2s are 10, 5 5s are 25, 5 5s are 25. So it is 5 to the power 1, 2, 3, 4, 5. So it is 5 to the power 5. So 2, it does not appear, but we know that n number raised to the power 0 is equal to 1. So in place of that, we can write 2 power 0. So since this number, since 3, 1, 2, 5 can be expressed as 2 to the power n into 5 to the power m, it has 13 divided by 3, 1, 2, 5 can be expressed, or this number has a terminating decimal expansion, has a terminating decimal expansion. This way you are going to solve it. Just you have to check the denominator or the q term, whether you can write like this or not. 2 power, 5 power, you can raise it or not. Let us see the second one, this is number 2. 17 by 8. 17 by 8. And here also prime factors of 8 will find out. 8 is 2 into 2 into 2, or we can say 2 to the power 3. 3 times 2 is 8. Into, here 5 does not appear, but we can write 5 to the power 0. So in this case, since 8 can be expressed as 2 to the power n into 5 to the power m, therefore 17 by 8 also has a terminating decimal expansion. If we divide it, the decimal expansion will terminate, it will stop. Likewise, let us do the third one. 64 by 455. In this case also find out the prime factors of 455. 455 I'll find like this: 455, 5 9s are 45, then 5 1s are 5, 3s or 7 1s are 7, 7 3s are 21. So it comes out here as 5 into 7 into 13. This time 2, if you put also 2 to the power 0, these two numbers are coming extra. So it's not required. We need only the factors of 2 and 5. So here, since 455 cannot be expressed as 2 to the power n into 5 to the power m, therefore 64 by 455 has, you write this one, a non-terminating, has a non-terminating repeating decimal expansion. So like this you have to do. If any other factor comes in between 2 and 5, then it will have non-terminating repeating decimal expansion. To do this second question, to write down the decimal expansions for those rational numbers in question number 1 above which have terminating decimal expansion, you can proceed this way. You don't have to do which does not have terminating decimal expansion. This one don't need to do. Those which they have terminating decimal expansion, those questions only you have to do. So here what you will do is 13 divided by 3125. You got like this. 13 divided by 5 to the power 5, you got it. So what you will do is, in the numerator also you will multiply by 2 to the power 5, denominator also multiply by 2 to the power 5. Then what you will get here, 13 into 2 to the power 5 is 32. 2 5 times, 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. Then downside why we are doing this is multiplying and dividing by 2 to the power 5, so that 5 2s are 10 you have. 10 to the power 5 is common, power is common. Then what you will get is 32 into 13. 13 to 26, 13 3 39, 40 41. So it is 416. And 10 power 5 is 1 2 3 4 5. So you can count the digit like this: 6 1 4. This is 1 2 3 4 5. Then put a decimal, so you can get the terminating decimal expansion. This way you can do. And the second one, when you do, here you have 17 by 8. This is 17. 8 is 2 to the power 3. So you multiply by 5 to the power 3. This 2 to make it 10. And here also you multiply by 5 to the power 3. 17 into 5 to the power 3, 125. 5 5s are 25. Again 25 into 5 is 125. Divide by, here it is 10 to the power 3. Both the powers are same. These two get multiplied. So here what you will get is 125 into 17. Multiply 35. 7 is 14, 15, 16, 17, 7, 1 in hand, 7, 8, 5, 2, 1, 5, 12, 2, 1 in hand, 11, 1, 1 in hand, 2, 2, 1, 2, 5, 2, 1, 2, 5, and divided by 1000, 10 power 3. So here also 1 digit, 2 digit, 3 digit, then decimal. Here 3 zeros are there, then in front you have 1, 2. So this way you can find out the terminating decimal expansion. And if you find difficult like this to find out, to multiply and divide by the same numbers, you can even go for division. This one you can divide also and find out. Like this you can do. This way you can do it. 13 divided by 3125. Cannot divide 0. 0 you put decimal, again 0 you put decimal, still cannot divide 0, and again 0 here. Then you can divide 3 4s are 12. So 4 5s are 20, 0 2 in hand, 4 2s are 8, 9 10, 0 1 in hand, 4 1s are 4 plus 1 is 5, 4 3s are 12. So 500 you will get here on subtraction. Then 0 if you put, then one time you can do it. 3 1 2 5. This is 5, 9 minus 2 is 7, 9 minus 1 is 8. This is 1, and again 0 you can put it. Then 3 6 are 18. So nearly 6, 30, 0, 3 in hand. 6 2 are 12, 10, 15, 5, 1 in hand. 6 1 6 7, 6 3 are 18. So like this also you can do. If you cannot write down this way, 13 by 3 1 2 5 equal to, directly divide it and then you can write on the answers. Like this you can present it. Question number 3. The following real numbers have decimal expansions as given below. All the 3 numbers that you can see, they are given in terms of decimal expansion. Everyone is in terms of decimal expansion. In each case, decide whether they are rational or not. First of all, you have to check it whether they are rational or not. So whenever decimal expansion is given, your definition for a rational number, you have to know it very nicely. I'll write down here: non-repeating as well as non-terminating decimal expansions are called irrational numbers. So it should be both non-terminating as well as non-repeating. Non-repeating as well as non-terminating. Then that decimal representation will be called as irrational numbers. So first of all, our work is to choose which is rational and which is irrational. So look here, it is terminating. We require non-terminating, non-repeating for irrational number. So since it is terminating, so it is a rational number. First of all, this is a rational number. Now let us see here the second one. It is non-repeating. Non-repeating how? Because it is after decimal 120, 1200. Next is 12000. So they are not the same. All different. This is non-repeating, as well as it is non-terminating. You can see here dot is given. Non-terminating means non-stopping, non-stop. It is going on. So it comes under irrational number. It comes under irrational number. And what about this one? It is non-terminating because bar means it is, again the number is going on. Same number 1 2 3 4 5 6 7 8 9 here 1 2 3 4 5 6 7 8 9 1 2 3 4 5 6 7 8 9 like that is going on. It is non-terminating. Very nice, good, but it is repeating. The same number is repeating. It's not following this one. Non-repeating. This term, this word is not following. So it will also come under rational number. This is also under rational number. Like this we distinguish which is rational and which is irrational number. Now the question is, the second part of the question is, if they are rational and of the form p by q, what can you say about the prime factors of q? So this is rational. So when you do the solution, number 1 you write down 4 3 43.12345 6 7 8 9 is a rational number. It is a rational number. First answer you give like this. After that, if they are rational and of the form, this one can be written in the form of p by q. We all know this decimal, if you remove it, downside will divide by 1. Then how many zeros you have to put? 9 zeros. 1 0 0 0 0 0 0 0 0 0. Then it will become p by q. What can you say about the prime factors of q? Saying the denominator, the prime factors of q will be of the form, what form it will have? It's a terminating decimal expansion, so it will be in the form of 2 to the power n into 5 to the power m, where m and n are positive integers. Like this you have to write down. Now the second one, when you do number 2, then directly you can say that we have already detected that it is irrational number. It is not in the it is non-repeating as well as non-terminating. So it is an irrational number. So nothing you can say about the prime factors of q there. Now you will say that 0.12001200012000000 is an irrational number. Is an irrational number. Like this you will do. Again, the third one, you write down 43 point. This is the third one. Now when you do the third one bar is there. Is a rational number, and the prime factors of q will be of the form 2 to the power n, 5 to the power m, where m and n are positive integers. Like this you can conclude it. Thank you and have a nice day. Stay tuned with LFI Educates.